Now that our system is created, I'm going to press next. This brings us to the feed stream. And we know that the feed stream has a temperature of 330 Kelvin. And we are told that it is high pressure. So I'm going to input 20 ATM. We are told that the total flow rate is 163 kilomoles per hour, which we have. All right, so in this composition area, we are given mole fractions. And we know that N-but is 90%, so 0.9. We know that I-pentane is 0.1 and isobute is 0. And now we are done with this page, so I'm pressing next. And this is the page about the duplicator block, which we don't need to input anything, so I'm pressing next again. So now we are defining a CSTR. So I'm going to put the pressure of the CSTR at 10 ATM. And because it's an adiabatic system, we want to select duty and have the heat duty set to 0 watts. Because this is a liquid system, we only want liquid for the valid phases, liquid only. And for the CSTR volume, I am going to just put a guess of 3 cubic meters. And now I'm pressing next. So since we defined our reactions before, they are in the available section right here. If I double tap, it is now selected. And we have done everything on this page. So now we are moving on to defining our PFR. So for reactor type, we want an adiabatic reactor. And next we will fill out the configuration. So for the length, we were not given a length, so I'm going to put 1,000 meters with a diameter of 0.1 meters. And you can input whatever you want. We will be looking at our results from 0 to whatever length you put for the conversion. Once again, for the valid phase, we want liquid only. And once again, for the PFR reactions, we want to select R1. This time when I selected next, it says required input complete. Do you want to run the simulation? I'm going to say okay, and the simulation will start running. The control panel will automatically pop up, and it will tell you if you have any errors or warnings, and I don't have any, so now the results are being generated. So once the results are generated and you want to look at them, you're going to go up to the very top and select Stream Summary right in the middle. This is going to show you the feed streams, the product streams, and all sorts of things about them. So I'm going to look down at the mole flow. And as you can see, we have 146.7 for N-but for the feed. And in the CSTR, the outstream is 60. And for the PFR, the outstream is 41.6. So since we want to learn more specifically about the PFR, I am going to go over to the left-hand side and pull up more information for the PFR. So on the left-hand side, PFR, I'm going to Profiles. And under View, I'm going to change it to molar composition. Here you can see the length from 0 to 1,000 and the conversion. So for the first goal, we want to determine the best volume for 70% conversion of N-butane. you can see that around 300 meters, the conversion is almost 70%. So the best volume is going to be somewhere between 300 and 400 meters. To find the maximum conversion, you can see that as we reach around 500 meters, there's not much more conversion happening. It reaches 75%, and that's about it. So the maximum conversion is 75%. All right, so our last goal is to determine the CSTR volume to have 40% conversion. And there are a few more steps to do that. So in the left menu bar, scroll until you find design specs, which is sometimes hard to find. It should be under flow sheeting options and open design specs. So here you're going to select new, and I'm going to leave the ID as DS1. So this is where you define your variable. I'm going to say CSTR conversion. And basically what this is all doing is you are saying, I'm going to set this at this specific value. So for us, we are setting the conversion to be exactly 40% out, 40% conversion of the N-butane in the product stream from the CSTR. And then we are going to vary the volume to find the best volume for 40% conversion. So now that we've created our variable, we need to say the category that it is in. So since we are doing conversion, which we are stating it as a mole flow out of the CSTR, we're going to select streams. And under reference type, we are going to select mole flow. For the stream, we're saying the product of the CSTR, and component is N-but, and the unit should be kilomole per hour. I'm pressing next, and on the spec page, for spec, you want to write the exact name of your variable. So CSTR conversion. And the target is what you want it to be. So for 40% conversion, that was calculated to be 86.4 flow out. So 86.4. And the tolerance I'm going to set to 0.01. So next on the vary tab, this is where you're going to select what you want to vary. So for type, I'm going to select block vary because that's we are looking for the block CSTR. And the variable we're varying is volume. So I'm going to scroll down until I find vol. And we want cubic meters. For the variable limits, I'm going to set a lower limit of 1 and an upper limit of 10 with a step size of 1. Actually, I'll do a step size of 0.5. All right, we are all done here. So I'm doing next and running the simulation again. So to see the results from here, in the left menu, you want to scroll down. And in results summary, you are looking for convergence. So here you can see we have a negative error. So let's go back and see if we can fix up something in what we just filled out. So I'm going to go back up and look for DS1. And under step size, I'm going to change it back to 1 and see if that works. All right, so now I'm going to look back in the results summary for convergence. The error is now above 0, positive, and the variable value is 1.31. So this tells us that for 40% conversion, we should have a CSTR with a volume of 1.31 cubic meters.